There I am. Hello. I'm going to start all over again. Right, where did I begin? So, bit of an unusual problem, a bit of an unusual video from me. I've been doing the Fortnite streaming and I've been doing the Python streaming. So, looking at a data science problem on Kaggle and how to essentially run some Python code to get results on the board and then how to tweak those results. It's a bit of a different video. I was looking at the Fields. There was an article in the news about the Fields Medal, which is obviously at the top end of maths, and I thought I'd make this video about a problem which is at the other end of maths, but I think I have a nice simple way of explaining it. Maybe you'll stumble across this video because you've searched for it, because you're looking for an explanation of why this thing is, and perhaps I'll be able to help. So let's have a look at this. So you may have learnt that x plus 1 squared is equal to x squared plus 2x plus 1. And there are various different normal ways of showing this. So you might have learnt to cross multiply. So x plus 1 squared is equal to x plus 1 times x plus 1. And then you multiply out. So I'm going to use the mouse for this, which is great. So x times x equals x squared. X times 1 equals x plus 1 times x plus 1 times 1. So you may have learnt, I remember learning that at primary school. You cross multiply, you do this one times this one times this one, then you do this one times this one, and then you do this one times this one. Okay? And you also might approach it with the binomial theorem, I think is applicable here, which I won't go into. But another way of looking at is it's a row in Pascal's triangle. So I could have put some more information in here, but x plus 1 to the 0 would be the first row. X plus 1 to the 1 would be this row. So you'd have 1 times x plus 1 times 1. And then the next row, this is Pascal's triangle, and the third row is x plus 1 squared, where you get x squared, so 1 times x squared plus 2 times x plus 1. And then, just for completeness, or just to give the next row so that you see the pattern, the fourth row in this would be x plus 1 cubed, and it would be x cubed plus 3x squared plus 3x plus 1. Okay, fine. So those are kind of normal ways of not explaining, but deriving or calculating what, x plus 1 to the 0, or x plus 1 to the 1, or x plus 1 to the 4, and so on, what the answers to those things are. Okay, but I'm going to show you a way to show that x plus 1 squared is equal to x squared plus 2x plus 1, which I think is more intuitive and perhaps will help you to always remember that that is in fact the answer. So I think if I do some undos, that disappears and that disappears, and I'll leave this in the corner. So let's do some 2D shapes. I am going to draw a square, so let's accept that. Whoa. Okay, slightly wonky square, but I'm sure that you can see that it is a square. It's one of the earliest square numbers. I suppose, would you call it the third one? You have 0 squared, which is 0. You have 1 squared, which is 1, and then you have 2 squared, which is 4. So, let's have a proper square. So we've got a proper square, 2 squared, which is 4. Okay, so what are we trying to do? Well, in the context of the expression in the top left corner here, this square here is x squared. In this instance, I think x is 2. Okay, and what I'm going to do is I'm going to carry on with it and all will become clear, I hope. I'm just using the black and the white to try and explain things a bit better. Okay, so I want to explain this very simply. We started with a square that's 2 by 2. We now have a square that's 1 bigger, that's 3 by 3. The bigger square you could describe as x plus 1 squared. So the smaller square is 2 squared and the bigger square is 3 squared. So you can see that the difference between the first x is 2 and the second x is 3. So the difference between the two is 1. So the big square is clearly x plus 1 squared. It's 3 squared. And the smaller square is x squared because it's 2 squared. Because I do know that, sometimes it's difficult. Well, what's x? Well, in this case, x is 2. But x could be 5 or 10 or 15. If x was 15, we'd start with a square of 15 squared, and then we'd increase it by 1 to get a square that was 16 squared. And this is where I'm hoping that you can start to imagine how that would look, because you can see that no matter how big you make this original square, the rules are always going to be the same. So what I want to do is I want to say x plus 1 squared. So I'm going to write that. I'm going to write it here. X plus 1 squared, which is in this case 9. X plus 1 squared equals x squared. I'm going nice and slow. Equals x squared. X plus 1 squared equals x squared plus 2x. Okay? X squared plus 2x. Plus, can you see where I've gone with this now? To begin with, you probably thought, what's he doing? And hopefully you're not thinking that anymore. Plus 1. So hopefully you can see how if you'd started with a much bigger square, the kind of geometry of the situation means that you'd get the same answer. So if the original square was 5 by 5, then the way to make it 1 bigger would be to add 5 across the top and then 5 across the right hand side, and that would always leave one little gap where you have to put a 1. So if you don't believe me, then have a go at drawing your own. Draw one that's 4 by 4, and then you can see that to make a square that's 1 bigger, you start with 4 squared, you add 2 4s, and you add a 1, and that gives you a 5 squared. And let's just so what did we just say there? We said, well, we know what 4. So what are we actually trying to do here? We're starting with a number 4 squared, and we're trying to derive the value of 5 squared. Okay, so we're starting with a number x, which in this case is 4, and we're trying to work out what x plus 1 squared is. Well, 4 squared is 16, and 5 squared is 25. And 4 plus 1 squared is equal to 16 plus 2 4s. So 16 plus 4 is 20, plus 4 is 24, plus 1. Guess what? It's 25. So I hope that doesn't muddy the waters, but I think the crucial thing is it's very easy to visualize with 2 square and 3 square. You can see how, and I'll use the mouse, x plus 1 squared, which is this box here, this square here, is equal to x squared, which is the initial square, plus these 2 on this side, 2 on this side, always leaves a gap which you have to put 1 into. And so you get x plus 1 squared equals x squared plus 2x plus 1. And the other point is, it doesn't matter how big x is, you can see that this always applies. And I'm going to leave it there. So there we have a bit of maths. Thank you very much. Oh, and before I go, if you've found this video useful at all, please like, please subscribe, please ring the bell so that you will get notified of future videos. There's another thing now, isn't there? If you're on your laptop and you ring the bell, it'll ask you whether you want all notifications, and that would be really helpful if you did get all notifications, because it means you might be able to watch some of my future videos. I do a combination of various different things, but I do want to do some more maths and programming type videos. So please come and join me, and we'll do it all on a different subject sometime soon.